Hello, my name is Kai Iverson. This is question 4 for group 7, 311. So the question goes, let f of n and g of n be asymptotically non-negative functions. Using the basic definitions of theta notation, show the following. The max function of f of n and g of n is equal to theta of f of n plus g of n. Alright, so the first thing that I'm going to do is start off with the definition of theta. So we say that w of n is equal to theta of q of n if there exists constants a and b such that a times q of n is less than or equal to w of n, which is less than or equal to b times q of n. For all n greater than c for some c. Alright, now for the actual proof. So we're trying to find a constant a times f of n plus g of n is less than or equal to the max function of f of n and g of n is less than or equal to b of f of n plus g of n for all n greater than constant c. Alright, so starting off with a, we can derive that by starting off with f of n is less than or equal to the max function of f of n and g of n. And we know this because if f of n was bigger than g of n, both sides would be equal, and if f of n was smaller than g of n, the right side would be bigger. And the equation also holds true for g of n is less than or equal to the max of f of n and g of n. Alright, so the next part, using a little algebra, you can figure out that 1/2 of f of n plus 1/2 of g of n is less than or equal to 1/2 of the max of f of n plus g of n plus 1/2 of the max of f of n plus g of n. That should actually be commas. Well, anyways, factoring out the 1/2, we can get 1/2 f of n plus g of n is less than or equal to max of f of n plus g of n. And that means that we've found a because it looks exactly like what we were trying to find, the first part. And 1/2 is where a is supposed to go. Alright, now for b. So we start off with the max of f of n or g of n is less than or equal to f of n plus g of n. And the max function can either be f of n or g of n. We can output one of those. But the right side, f of n plus g of n, is both f of n and g of n, which we know is asymptotically non-negative. So both of those combined will always be higher than the max function. And from that, we can derive that the b is a value of 1, because you can factor a 1 out. That's just how algebra works. Alright, so now to find c. We start off with f of n is less than or equal to f of n plus g of n. And, well, g of n is asymptotically non-negative, so we know that that will be true after some point. And we'll call that point c1. And then the same is true for the other side for g of n. And we'll call that c2, the point where the equation is true. And then, so yeah, if we just choose the higher of c1 and c2, use the max function on that, both equations will be true because they're both true at that point. So yeah, we have the c. C is just max c1 and 2. Okay, final notes. A is equal to 1/2, b is equal to 1, c is equal to max of c1 and c2, as c1 and c2 are defined in the c exists section. Since we have found what a, b, and c are going to be, that means that we have proved that the max function of f of n and g of n is equal to theta of f of n plus g of n. That concludes my proof.